When a chemical reaction is actually carried out in a laboratory, it's very rare that both reactants will be present according to the balanced equation, so the stoichiometry values in front of the coefficients in front of the reactants, which means that one reactant will be consumed first, and this is what we call the limiting reagent. The one that isn't consumed first is called the excess reagent. So the one that doesn't have enough quantity to allow for a complete reaction, that is the limiting reagent. Because there isn't enough of it to fully react the other reagent, it limits the amount of product that will be produced. So it's the limiting reagent. So I'm going to look at kind of a little bit of a long stretch, an example of making cheese toasted sandwiches. So we have 12 slices of bread and 5 slices of cheese. Our balanced reaction would be 2 bread plus 1 cheese gives us a sandwich. Stay with me here. I know you're probably thinking, thanks, Ms. Bloomer. This is a little bit of a weird example, but hopefully it helps you understand. So I make 1 sandwich, put 2 slices of bread, 1 slice of cheese. 2 slices of bread, 1 slice of cheese. I've used 3 slices of cheese. 1, 2, 1. 1, 2, 1. So now I've used up all my slices of cheese, 1, 2, 3, 4, 5 slices of cheese, and I've only used 2, 4, 6, 8, 10 slices of bread. So my cheese is limiting, but my bread is in excess because I've got some leftover bread from making the sandwiches. So if we're adding 4 hydrogen molecules and 2 oxygen molecules together, how many molecules of water could we form? I want you to think about that now before I give you the answer. They're all in their correct stoichiometry values. So this time, both of our reactants are used up completely. But what about if I have 4 H2, so 4 hydrogen molecules and 4 oxygen molecules? This time, there's going to be one that's limiting and one that's in excess. So I have leftover oxygen here, which means that the oxygen is in excess and the hydrogen is the limiting reagent here. So we're going to have a look at calculating an example. Your experiment number 12 also deals with limiting and excess reagents, and you'll need to be aware of them when you're doing your experiment for your assignment. Sodium metal reacts with chlorine gas to produce sodium chloride. What mass of sodium chloride forms when 143 grams of sodium reacts with 191 grams of chlorine? So we need to start with a balanced equation. So let me just get a kind of nice colored pen. I'll have sodium solid plus chlorine gas gives me sodium chloride, which is a solid as well. My sodium is balanced, but my chlorine isn't, so I'll have to put a 2 out the front here and a 2 out the front there. So now it's balanced. Now I want to use the mass that's given the equation to calculate the number of moles of each of the reagents, each of the reactants. So I'll start with sodium, and I think that I might have to work across the page to be able to fit it on this page, so we'll see how we go. So the number of moles of sodium equals the mass divided by the molar mass, which equals, how much did it tell me? 143 grams divided by 23 grams per mole, which gives me 6.22 moles. Do the same for chlorine. So the number of moles of Cl2 chlorine equals the mass divided by the molar mass, which equals 191 grams over 70.9, which gives me 2.69 moles. Okay, now I'm going to determine which one of my reagents is limiting and which is in excess. So I need to look at a ratio from my balanced equation. So I'm going to look at my number of moles of chlorine to my number of moles of sodium. From the balanced equation up here, chlorine's 1, sodium's 2. So I'm going to put 1 over 2. So now I can calculate the number of moles of chlorine based on the number of moles of sodium I have. So the number of moles of chlorine that will react equals the number of moles of sodium multiplied by 1 over 2. So this will be 6.22 multiplied by a half, which equals 3.11 moles. So for all of the sodium to react, I need 3.11 moles of chlorine. But we just calculated that we actually only have, given the information from the question, we only have 2.69 moles of chlorine, which means that my chlorine is the limiting reagent. It's going to limit the amount of product that can be formed from this reaction. Okay, now using our ratio and the number of moles of our limiting reagent, so that's our chlorine, we're going to calculate our number of moles, so the amount, this is number of moles, of sodium chloride formed, because that's what the question is asking us. So I need to start off with my ratio from the balanced equation. So number of moles of sodium chloride to the number of moles of chlorine is 2:1. So the number of moles of sodium chloride produced, and this is the same thing that we've been doing the whole way with our stoichiometry, is 2/1 multiplied by 2.69 moles, so the number of moles of chlorine that are reacting, which is 5.38 moles. I think the question asked us for mass, so let me just double check. Yeah, it's asking us for mass, so now we'll go the mass of sodium chloride produced, sorry about the squishy working out here, obviously this should flow down the page, equals number of moles multiplied by molar mass, which equals 5.38 moles times by 58.5 grams per mole. So I'm going to have 315 grams of sodium chloride produced by this reactant. And then you can also calculate, the question isn't asking us for it, but you can also calculate the number of moles of excess reagent. So remember, our chlorine is limiting, which means that we're going to have leftover sodium left in the beaker. So number of moles of sodium produced is, from our reaction, we know that it's 2 times the number of moles of chlorine. So 2 times by 2.69. So only 5.38 moles of my chlorine are going to be produced. To figure out what mass this is, mass multiplied by mole mass, so I'm going to go 5.38 moles multiplied by 23 grams per mole, which gives me 124 grams. So in excess, I started with 143 grams, so take away 124 grams. So I'm going to have 19 grams in of sodium in excess left over. So that's limiting and excess reagents. So obviously, if you're reacting some kind of mass, let's say of calcium carbonate with some kind of acid, you'll need to determine whether you have given the reaction enough acid to completely react the sodium chloride. So if you're testing an eggshell, you should be calculating it as if, okay, if this mass of eggshell is completely 100% calcium carbonate, have I given it enough number of moles of acid based on the concentration and the volume for that reaction to proceed? If not, you'll need to give it more